So, very good evening to all of you. Am I audible? Just let me know.
Yes, ma'am.
Okay. Yes, ma'am. All right. So, today we are going to start with another new topic is vibration of structures. Okay. So, before starting with the vibration, and first of all, this is a very important topic. Vibrations of structures. Mostly, it is based on formula based, and some of the types are there, standard types. So you have to remember the formula and some of the standard types and patterns to solve the problem. Okay. Now, before starting, as I have said, that I'll be solving one of the problem that you are asked me to solve. That problem was based on shear center, right? So I think that question was from gate 2010. So in the given problem, they have given you this structure, right? And they have given the height h, they have given the flange was also h, distance between this and all they have given as h. Right? Sorry, h by 2. Okay, this is along the x and this one along the y they have given, and ixx they have given 35 by 12 THQ. I hope these are the given data, and the question they have asked to find out the shear center for this section. Okay, now since it's a combination of can see C section, so just recall the general formula in terms of this Ixx. Okay, in terms of this Ixx. So shear center is B square H square T by 4Ixx. This is the general formula for this, isn't? So here the B defines H defines twice of H, T is constant, thickness is constant T, and Ixx has been given over here. Now first of all substitute the value H square into 4H square into T by 4. In place of Ixx, substitute the value of 35 by 12 THQ. Now cancel off the terms. This T, right? This you just get cancel off 3. So what you get finally? 12 by 35 H. You get something like that, isn't? Now please tell me what is this value when you solve this thing? What is the value you get? 12 by 35. What is the value?
Ma'am, it's the location of shear center of this capital C.
Yes. No, I'm asking that what is the ratio of 12 divided by 35? What is the fraction value you're getting? Please calculate and tell me the value.
Ma'am, 0.342.
0.3428.
3428
8.
of H. Okay. Now this is the thing which I have only considered for this C section, isn't? Now what I'm gonna do is, now we have the four options they have given. Okay, we have four options. What was the four option? 3 by 8 into H, then 9 by 28 of H, then another was 35 by 36 of H. Now you find out the fractions for this thing. Another one was, I think, 17 by 35 of H. Right? Now tell me the fraction values.
9 by 28.
3 by 8 means how much?
0.375.
0.375. Okay. Then next one?
0.321.
0.32.
32. Okay. Then next?
Yes, ma'am.
Next one?
0.972.
0.97
97.
of H. And the other one?
0.485.
0.485.
Okay. Right. Now here we have got this value. Okay. 0.3. That means it should lie within this two range. Now how to find out that whether it will be this fraction or this? That means we always know where the shear center locates. Just I request all of you to mute yourself. Yes, thank you. Okay. So we know in this C section it will locate on somewhere in the X direction, and it should be outside. And it should be outside, isn't it? So we have to know that somewhere here it will locate. Now where it is. Now if I have the two options, now 0.32 and 0.375. Now you have to use some kind of reasoning facts to find out this answer. Now if I say it is 0.32 and 0.37, these are 2 points. Let's consider this is 1 point, this is 2 point. Now this is x1, this is x2. Now the x3, let's consider this is x3 point, that is 0.428 that we have got. Let's consider this is that point. Okay. Right? Now this is the point where we have got this value. Now since our system, this is the only for the C value, we got this x3 value. Right? Now here we have another component. Now x2 is coming closer to this web. This is a vertical component, that is a web. So if I consider the x1, we cannot, the point, the shear center is a point where it will not lead to any sort of twisting force or twisting moment. Okay, the twisting angle should be 0 at that point. So it is obvious from the reasoning that since this member is located over here, it has to locate somewhat far away from this web to locate the shear center. Right? So I hope the right answer is 9 by 28.
Yes, ma'am.
Okay, so that's why the right answer will be 9 by 28. Right? We have to see that location on the points, which one is the farthest one. Okay?
Ma'am, X1 lies farthest, na? It's 0.375.
Sorry.
Ma'am, X1 lies furthest from this web.
Further, X1. Okay,
Yes,
okay,
ma'am.
okay. All right, 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 right. Then the right option should be X1 only.
Ma'am, but the correct answer is X2, 9 by 28.
Um,
Yes, ma'am.
but right, right. See, in my answer booklet, I'm having the right option is 3 by 8H. Yes. I will share the solution with you also.
Eh,
Okay. I'm having the right option as 3 by 8 only. Yes. This is only I'm having that. Okay.
Yes, ma'am.
Ma'am,
Ma'am, after the
my
class, could you
book.
please share the? Acha.
Yes, yes.
Continue.
I will share that. Okay.
Yes, ma'am.
All right. Now, shall we move to the
Excuse me,
today's
ma'am.
agenda? Yes, please.
Ma'am, in my textbook, they have given explanation, ma'am, regarding that the answer, ma'am.
I'm unable to get it. Please. There is a glitch in your voice.
Regarding that answer, ma'am,
Hmm.
share center, ma'am. Regarding share center, they have
Hmm.
given explanation, ma'am, answer. I will share it, ma'am, like on
Okay.
WhatsApp.
Okay. Okay. Sure. Sure. Okay. All right. Now,
Okay.
today we will move to our today's agenda is a vibration of the structure. Now, before moving to this vibration, I would like to skip this like basic definition part. That is, what is periodic motion, what is time period, what is mean by frequency, amplitude, it having lot many different kinds of you can say terminologies or definitions. Okay, so already you know what is mean by vibration, what are the periodic motions, right? So today we will skip those things, right? So already you know what is that mean by frequency. That means whenever any object is subjected to any sort of loading, right? So each and every body or a material have some kind of elastic limits. So due to that, when it regain back to original state, it will lead some kind of um, vibrations, right? It will make some kind of to and fro motions. Okay, so that to and fro motions, right? That what is a number of cycle per unit time. So when we check that the number of cycle per unit time, that says the frequency. Okay. Now frequency can be denoted in two forms. Okay. So frequency, I will change to my slide. So frequency are of two forms. One we represent in of f of n. Another is omega suffix n. Both are of the natural frequency. Now, when we denote, if you see in the options, they have given something like radian per second. That means you have to find this one, omega suffix n. N represents the natural frequency, and f suffix n, if in your options, if you see they have given the unit as hertz, that means you have to find this fn. Now they have a one combination of that formula, that is fn equals to 1 by 2 pi root over k by m, and this root over k by m represents this omega n, whose unit is radian per second. So here you have to be very careful with the units, and you have to understand by seeing the unit that what kind of nature that they're asking you to find out, whether it is a natural frequency of this in terms of hertz or in terms of radian per second. And again I'm telling you, always the main motto of the gate is to make you confused. They usually ask a very, very, very basic thing, but the main motto is to make you confused, and they will give you the options in such a way that if you do a small reciprocal change in the substitution, you will get a different answer. Okay, so you have to be very much careful with that. Okay, now before starting, let me know how many of you have studied this subject. Just let me know in the chat box how many of you have studied this subject, because some of the university they don't have this topic.
Ma'am studied, but long back.
Okay, so but you have studied. Okay, you have studied. Right. Okay, no issues. So I'm not going, that's why I'm not going to the very basic things, that what is like a time periods, right? Time periods means it is a number of interval that any times how many number of amplitudes it will make, right? So all those things I'm not going. I'm straight away move to the core thing, that how to solve the problems, and what are the how to do those problems, right? Okay, now before starting that, you should know what are the basic parts of an vibrating system. Okay, what are the basic parts of vibrating system? Okay, now we have seen in some of the few classes back that what are the ways that vibration can leads, and how we can absorb, how we can diminish those vibrations, and how what are the precautions that we take care for an aircraft, right? So we have discussed about the buffet, we have discussed about the flutter thing, right? So apart from that, now here we will focus what are the basic vibrating system. Now basically when we talk about this vibrating system, first we have the mass. Whenever there is a mass, it will leads to some kind of vibration. Now basic vibrating system, then next comes the spring. Okay, next it will be a spring. Then the third one will be the damper. Okay, the third one will be the damper. So these are the basic elements of an any vibrating system. Now again, here this how the equation of motion of this such a vibrating system, right? There is a huge derivations. Again, we are not going or focusing on the derivation, but yes, the equation of motion is very, very, very important. You should know this equation of motion of a vibrating system. Okay, now you should remember this. The formula is very simple: m x double dot plus c single dot plus k x equal to 0. Now when I am equating to 0, that means I am considering it's an free vibration. Now vibration can be of free vibration and the forced vibration. Now free vibration, by the name itself we can say it is generating the vibrating by itself, right? Force means some of the external load or some kind of thing is acted on a body or a system, which will lead to an force vibration. Okay, now this m defines this mass, k defines the spring, okay, stiffness, and C defines the damper. You have to remember this notations. The K represents, spring represents in terms of K, M represents the mass, C represents the damper. Alright? Now, sometimes in your problem, they might also give you in this way. The combination of this M into X double dot represents the inertia force. Okay, if they are giving the inertia force, means they have given this M X double dot C X single dot means it is a damping force. Okay, they have given the damping force. The next one represents the K into X represents the spring force. Okay, Kx represents the spring force. Right. Now already I have said how to find out the natural frequency. One is when omega represents K by M. Okay, and if you have to give in terms of hertz, that is unit is radian per second. Now when you want to find in terms of hertz, you have to use this formula K by M. Okay, now it can also be written as 1 by 2 pi can be written as G by del. Okay, G is a gravity, that is 9.81, and del is a deflection. Okay, del is a deflection. So from here we can conclude one more parameter, very important conclusion also we can say, that is spring stiffness equals to load by deflection. Sometimes some of the problem you need to use this concept. Okay, stiffness, that is a K. Okay, K equals to load by deflection. That means I can say that K equals to mg by del. Okay, so this has been derived from this formula, that is here we are taking K by M and here G by del. Del is the deflection of any beam or whatever it is. Clear? Have you noted down this formula? Shall we move to next?
Yes, ma'am.
Okay. All right. So okay, I already have discussed this thing. Now sometimes in your competitive exam, right, already have discussed this formula, right, f of n equals to 1 by 2 pi. I hope I have written 1 by 2 pi before. Yes, 1 by 2 pi root over g by del. Now if you substitute the value of g, you know the value of g, right, that is 9.81. So you will get this value. Now this is f means in terms of hertz. In terms of hertz. Okay. And some of the textbook, instead of K, they have written as S. Right? Either of the convention. So here always I mention that convention is not that important, but understand the concept. Right? So the stiffness K can be say as, that is mg by del. Okay. Now there are a lot many different kind of vibrations. Okay, it can be of free vibration, force vibration. It can be linear, non-linear, damped, undamped. Okay, Then it can be longitudinal, it can be transverse, it can be torsional vibrations, right? All those theoretical part I'm not focusing again, right? All those things I will provide that in the notes, right? So that you can take care. Now we will now move to next slide. Okay, now we will do some of the problems. Okay, yes, that how to find out the magnitude of natural forces when the springs are in series and are in parallel. Okay, now here many most of the times they ask a question from this kind of thing, so we will focus about it. Now first one we will see, this is a first case for the when it is in series. So you can see there is some kind of fixed zone. From there we have three different types of springs, K1, K2 and K3. Okay, these are the stiffness for the spring, and this x1, x2, x3 are the extension of this each springs. That means it will have the displacement of x1 for two second spring having displacement about x2 and having the third one x3. Okay, now derivation is not important, but when the springs are in series, to find out the equilibrium stiffness value, right? Equilibrium, we can write K suffix equilibrium, right? To find out that, we can find like this way: 1 by K equilibrium equals to 1 by K1 plus 1 by K2 plus 1 by K3. Now need to solve this thing. So when you solve K1, K2, K3, and you get like K2, K3 plus K1, K3 plus K1, K2 by 1 by K equilibrium. So K equilibrium becomes K1, K2, K3 by K2, K3 plus K1, K3 plus K1, K2, right? So you can solve and you can find out the answer. Basically, it should be the reciprocal of each and every element. Done. This is for in case of series. Now, what will you do when it is in parallel? That is a second condition. That is the second condition when it will be in the terms of parallel. Right. Now, what you do here? It is a fixed zone. It is in fixed zone. Now from this fixed we have another three different springs that are connected. Okay. Now what to do when they are connected in parallel? So to find out the equilibrium stiffness value, you have to go K1 plus K2 plus K3. Now here in this case, this will be the formula. In case of parallel. In case of parallel. Now, if they ask for this same system to find out what will be the natural frequency, so you know the formula for natural frequency, that is 2 pi by k by m. Now, you might have a doubt that which kind of k we should include here. So, you should include the k equilibrium, right? So, it should be of 2 pi by, that means k1 plus k2 plus k3 by m. Right? Now, can I write this in terms of like that? That is f of n equals to f1 plus f2 plus f3. That means natural frequency of this first spring 1, then plus 2, then plus 3. Can I write this? Please let me know. Can I write this way? Can I write?
Yes, ma'am.
Right? We can write this way. So sometimes, even in your competitive exam, you know how to find out the spring factors. So they might ask you the question in this way, that what will be the frequency changes, okay, based on the different kind of representation of this, right? And in your exam, there may be questions like combination of series as well as the parallel. So you have to resolve that problem and find out the answer. So we will do such kind of problems in upcoming slides. Okay. Now let's solve one problem. Okay. A very simple problem. Now here in this problem, I'm sketching that. So this is a fixed rigid place. So from here we have one spring, we have another spring. We have one mass over here of 5 kg. Here we have another spring and fixed. Here we is K3, K1 and K2. Okay. Now where K1 is equal to K2, which is 1500 Newton per meter. K3 value is 2000 Newton per meter. Mass is given. Now from here, find out the natural frequency in terms of hertz. In terms of hertz. And round off to 2 decimal place. This is a question. This is a question. Now, first of all, you have to simplify the things. Now, how this K1 and K2 are connected? How this K1 and K2 is connected? Isn't it parallel? Can I say this is parallel?
Parallel.
Right? So this K equilibrium, I can say that K1 plus K2. Now if I into 2, I get this much. Right? This is a equilibrium for this one I found out. Now here we have another K3. Now how I can consider this one and this one? Both are rigidly supported. Here is a mass. When such kind of system will be there, you have to consider that K3 and the equilibrium of 1, 2 is also connected parallel with each other. Okay. So what I'm going to do is to find out this equilibrium, final equilibrium. So K equilibrium of 1, 2 plus K3. What I will get? 3000 plus K3 is 2000. I get 5000. That is my final K equilibrium. Okay? Newton per meter. Now, they have asked to find out the natural frequency. So, we know the formula 1 by 2 pi root over K equilibrium by mass. Mass is known over here. How much? 5 kg. So, just substitute that. Okay? 5000.
When K3 is in series, no?
Sorry?
K3 will be in series.
Series, ma'am.
So it will be 1 by K equivalent 1 to...
No. How it is series? That's what I said. See, this is, if there is something like this, then this. And if they're connected like that, means then I can consider that they are in series. But in between, there is a mass. So when I solve this problem, so basically I will get like all are connected like this only. If I transform
Parallel.
this thing to another end, so they are both are parallel. That K1, K2, K3 are in parallel. But if there are connections like this way, that means these are parallel. When I combine that, this will become in series. This one and this one will become series. We will solve that kind of problem also. So where you will know that the difference between that. Okay? All right.
Yes, ma'am.
So here it is. Not at all. Oh, I just got deleted. Okay. Right. Now solve this thing and tell me the answer in the chat box.
5.0.
5.03.
5.03. It's in hertz. Right? Absolutely. Okay. So always focus on that question, that what is the round of number they have asked, whether it is round off to round off to integers, or round off to which kind of decimal places. That is very important. Now we will move to that one confusing kind of problem. So you will have the clarity about it. Okay. Let's solve one problem. So here also same kind of. Okay, this is rigidly supported. Now from here we have one spring, here also another spring. Okay, now from this junction point there is another spring. Now here we have another spring. Now from this junction point we have another spring. From this junction point we have another spring. Now from this junction point we have another spring, and then we have our mass. And let's consider all the springs are same, that is K. All are K, and where the value of K is 2 into 10 power 5 Newton per meter, and the mass they have given as 20 kg. And here find out the frequency in terms of hertz, round off to 1 decimal place. 1 decimal place. Suppose in your gate exam you are including more than, suppose they have asked you 1 decimal place and you are writing that 1.00, it will take as an error. Okay, the computer it will consider as an error. So try to avoid such kind of thing. Read the question carefully. Look into that how many number of decimal places that they are asking. If they are asking 1 means, even your answer is 1 means 1.0 you have to write. If you include 1.00, even whatever it is, it will answer will capture as 0. Whatever, even though you have found out correctly, it will consider as 0. Okay, so be very careful with the words what they have mentioned. Okay, right. Now here you tell me how you're going to solve this problem. Now first you should start with this thing. Okay, Now when you find out this, what kind of system it is? When you find this thing, whether that is in series or parallel, what it is? What will happen? You can write down in the chat box. Isn't there in parallel? So when you find this one in parallel, right? They are parallel. So what will be their equilibrium? K plus K, right? 2K. So now you find out this one. Now when you want to find this one, it will be something like this. Isn't it? Now this value will be this one. That is 2K. Then it is in series K, and then it is in parallel. So first you need to combine this together. Again, the combination of this, what? It is in series. To find out this equilibrium, you have to use this formula. 1 by K of equilibrium by 1 by 2K plus 1 by K. Right? So you need 2K, that is 1 plus 2, 1 by K equilibrium. You get 3 by 2K. To find out K equilibrium, you get 2K by 3. So this one becomes your 2K by 3, and this is K. To find out this value, again K equilibrium for this one, you get K plus 2K plus 3. You get 5K by K. Sorry, it will be 3.
3, ma'am.
Right. Okay. Then 5K by 3. Now this part is done. Next, you have to move to the next phase. That is this part. Right? You have to move to the next phase. How to find the next phase? Now, if you draw that, simplify that. Already you have found till here. Right? Till here you have found out. This one is known. So, this one is your 5K by 3. Then again you have K. Then again you have here is K. Right? Find out and tell me the answer. K equivalent. Now again you are going to find out this thing alone.
Ma'am, 13 by 8K.
It was 13K by
By 13 by 8K. 13K by 8.
13K by 8.
Yes. Ma'am, I am telling about this combination of these three.
Okay, overall answer.
Sorry, ma'am, I did some mistake. Sorry.
Okay, just check it. Just solve it very carefully. It's very simple. First, find out this one. Okay. When you find this one, what will you get?
Ma'am, it will become 5 by 12K. Combination of these three. 5 by 12.
Combination of this three will become
5 by 12K.
how much?
5 by 12.
5 by 12K.
Yes, ma'am.
K will be here only, right?
Yes, ma'am. Yes, ma'am.
5K by 12. 5K by 12. 5K by 12, isn't it? Now you got this combination. Now again we have in 5K by 12 into K. Then you have this mass here. Now combinedly what you get, it is in form of series, right? Of 12 by 5k plus 1 by k. 5k, 12 plus 5. So you get something like k plus 17 is k equilibrium. I think something has gone wrong. It is not 13, it will be something else. Please check the answer carefully.
5k by 17 I'm getting at last.
5k by 17.
Yes, ma'am.
No, it's not that. Till here, 5 by k is right. Till this thing is correct. After that, this combination is not right. Check this answer. Kindly check the answer and write down in the chat box.
13k by 8, madam sir.
13k by 8, absolutely. It is 13k by 8. It should be 13k by 8. So here it will be also, we don't have this thing. You will get 13k by 8 plus k. So here also you will have, things will change.
13k by 21.
Yes,
Final.
yes, absolutely. Final answer will be 13k by 21. Now what they ask here? They ask the natural frequency. Now here the answer is not over yet. So 21 by 13k plus 1 by k. So we will, sorry. So you will get 113k by 21. So substitute the value f of n equals to 1 by 2 pi k equilibrium by mass. And here again they have given us the answer in terms of round off to 1 decimal places. Round off to 1 decimal places.
12.5 hertz.
12.5
5.
12.5 hertz. Yes, which is within the acceptable limit. Right. Shall we move to the next problem? Okay. Now this is a very simple problem. Very simple problem. You find out and tell me the answer in the chat box. Very simple problem. Write down the options. You can solve within a minute. You can write down in the chat box. Yes, it's very simple. Here, both the K1 and K2 are in which form? They are in parallel. So we know the K equilibrium, whatever it is going to be K1 plus K2. Isn't it? K1 plus
Yes, ma'am.
K2. This kind of system, whenever you will see, you should know this is Ennis of parallel. Okay, parallel means you are going to sum up like this way. So we know that they ask only the stiffness, equivalent stiffness. So the right option is option B. All right. Next. Now this is a different kind of problem. Sometimes they will give you two different kind of systems and they will ask you what kind of natural frequency will vary with one another. Okay. So let's read the question and tell me the answer in the chat box. For the spring mass system shown in the figure, the frequency of vibration is n. They have given, instead of f of n, they have said the frequency of vibration is n. Now, what will be the frequency when one more similar spring is added in series as shown in figure 2? Okay, so what will be the natural frequency when it is added? Now, I can say, yes, you can write down the answer in the chat box again.
Ma'am, n by root 2.
Sorry, I'm unable to hear you properly. You can write B. Okay. Okay, let's solve and see that. Okay. So for the case 1, right? So represents what? 1 by 2 pi root over k by m. I can simply write that. But in case of series, I know k equilibrium becomes 1 by, for the case 2, right? 1 by k plus 1 by k, we will get 2, 2 by k. Then equilibrium becomes k by 2. Then when we want to substitute here, we get 1 by 2 n root over this k by 2 into m. Now we know this one represents the n. This is for 2. So n2 will becomes, right, n by root 2. Right? We can easily say. So the right option is option B. I hope all of you understood this problem. Right? Okay. Now, in your exam, you can obviously expect such kind of questions, right? So here we are not wasting much of time for solving. You can solve this kind of questions right now. So you can take down this question as your homework or for the level of your practice. Okay, please copy down this question. You can take down this question for your practice. Shall I skip to next? Please let me know once you're done. Can I move to next? All right. Now, before coming to this kind of problems, okay, let me tell you a few of the another case studies. Okay, different kind of problems. Okay. Now here we have one fixed. Okay. Now here also we have another fixed which is attached with one spring. Now here the spring is attached in a very different way, whose length from this end to the spring is L. Okay. And there is another point over here. Distance between this point to this point is A. Here another spring is there, K2. Okay. And here we have one mass. Okay. Now this is another very different type of problem. Now here, as I've said, in a vibrating system, there will be three components. Okay. Now what are the components? Mass, spring, and the damper. But here there is no damper. Okay. And second thing, when there is no damper and the springs from a rigid bar, okay, there is a bar. Let's consider from A, B, C, and D. Okay, in this rigid bar, there are two fixed zones. One is a point A, another is a point D. From D point to another end, it is joined. Then from the B point, another spring is hanging with a mass M. Right? So, how to find out for this kind of problem? Okay, how to find out the natural frequency for this kind of problem? Right? So always remember, whenever there will be a problem, something related to like this, okay, you have to solve in this way. There is standard protocols and the uh, standard format are there to solve. Okay, first of all, let's consider that at the point B here, okay, at the point B, a force will be acting, that is F of B. You can take B, you can do anything. Okay. Now here it is K1 and K2. Okay, you can take F1, you can take F2 also. It is up to you. So let's consider F2 force acting on the B point. Okay, along the B. Then and FD or F1, there is a force that will be acted on this the spring K. Now we can write in this situation, we can write a equilibrium equation, that is 2, that is at the point B into whatever the distance, that is A, should be equals to at the point C, what force we have for C or D, we have F1. What is the distance? Is L. Right? Is the L. Right? Now either of the way I can find out what is a force that is acting on any one of the form. Right? F2 equals to F1 into L by A. Right? Could you follow this?
Yes, ma'am.
Okay. Next,
But how both are equal, ma'am? Like
this is an
F2
assumption.
into A.
This is the assumption that we are taking. Okay, that is a static equilibrium assumptions. Okay,
If ma'am, one more point is there here between B and C, then how it will be?
B and C, one more
Suppose,
point.
ma'am.
Huh.
Yeah, ma'am.
Then we have
Then how do we write it?
we can write if one other spring is there. right? Another fixed point is there. So we will consider if it's a point E. Okay, so FE or F3 into whatever the distance we have, suppose L2 will be equal to L2. Now you have to take F2 dot A equals to F3 dot any one of the convention, you have to try to convert that in terms of this. If you have any other an additional one, the main motto you have to convert that any one of the form.
Okay.
Got it?
Yes.
Right. Now, next thing is you have to find out the deflection. Now, how this deflection will be forming and each and every points. How this deflection will be forming on each and every forms. So we know what is K. K is how much amount of load by what is the amount of deflection. We have seen that K is load into deflection.
Yes, ma'am.
We have seen that,
Load by deflection.
right? Okay. Now, using this method, or I can say this K by M, I can say it is equivalent to G by del deflection. To find out this overall deflection, now we will use this form to find out the overall or the total deflection. Okay, del equals to del 1 plus L1 by L2 of del 2. That is, whatever the deflection will be in the 1, we will substitute plus L1 by L2 into del 2. Right? When you solve, you will get one of the form. We need to substitute back in this equation. Right? So we know f of n equals to 1 by 2 pi root over k by m, or we can write 1 by 2 pi g by del. Okay? There won't be any difference with the g. G is constant 9.81, right? So we need to find the equivalent one or the total one, whatever it is, and we will get the answer for that. Okay? Follow?
Ma'am, how you write this total deflection delta is equal to delta 1 plus L1 by L2 delta 2?
There is a derivation. That's why I said there is a derivation. So whenever this kind of problems will be there, stated will be there, you sorry, okay. Here it won't be delta 1, sorry, L1. Here will be L by A. Okay, here will be L by A. Right? The bigger one divided by the shortest one with respect to each other. Now, if you have the third component, if you have suppose third component, so the bigger one, that is a total length, by if the second one is L2 by L2 into del 3. Okay, could you follow? Please let me know, then otherwise I will repeat.
Yes, ma'am. Yes, ma'am.
Right, with respect to the what is the distance for the second component, accordingly we'll find. Suppose this one is there. Now this is not there here in this given problem. This is not there, so we will ignore this part. Right? Okay.
Yes, ma'am.
Now second assumption is, now you might ask that what is del 1 and what is del 2 and how to find those combinations, right? So another set of assumption is that in this kind of problem, usually they don't ask, but you have to remember this conditions. Okay, this is the same condition that how you have solved for strain and stresses. That is F1 into del 1 equals to F2 into del 2. Okay. Now from here I can say what is del 2. Del 2 is F2 by K2 based on this formula, right? I know this is del 2. Now what is F2? The amount of mass that is acting over here, right? The mass is M, right? The mass is M. Could you follow? Could you follow?
Ma'am, again, this equation is also from derivation. F1 delta 1 is equal to
Yes,
F2 delta
yes,
2.
yes. F1 delta 1 equals to F2 delta 2. So from there you can write delta 2 equals to F2 by K2. Now we know from here F2 means what? F1 into L by A. So can I write F1 into L by A into K2? That is del 2. Can I write?
Yes, ma'am.
Now del 1 is F2 into del 2 by del 1, isn't it? So what is F2? Just now we have seen that is F1 into L by A. What is del 2? Del 2 is again F1 into L by A into K2, right? F1. This is F1 by F1. One of the F1 will get cancelled off. So you will get F1 into L square by A square into K2 equals to del 1. Now you need to substitute that in this del 1 and del 2 and you will get some of the equation. Right?
Ma'am, could you just repeat, ma'am? Like
Ma'am,
from del 2 equal to
ma'am, you solved it wrong, ma'am.
F1.
Sorry, I didn't get it.
Ma'am, this delta 1 is equal to L by A delta 2.
Acha, okay. Just give me 2 minutes. I will be back. Just give me 2 minutes, okay? Just give me 2 minutes. Am I audible to you?
Yes, ma'am.
Okay. Yes. Okay. Tell me, what is the issues here?
Ma'am, you solved this delta 1, na?
Yes.
So F2 by F1 ratio from that above equation is L by A. You took one extra F1 here.
Extra F1.
Yes, ma'am.
Uh, okay, let's see.
Repeat it, ma'am. Yes.
Let me erase this part. This is right? Where I've written this one? Other things are right?
Del 2, ma'am. That del 2 equal to F1 into L by A.
Yes. Now F1 into del 1 equals to F2 into del 2. This is fine? Right?
Okay. Okay.
Or else I can also write in this way also. Isn't it? Like if I want to find del 1, okay. Now what is del 1 from this equation? F1 by K1. Can I write? Now if I want to find del 2 I can write F2 by K2.
Yes, ma'am.
Let's make it this way. F1 by K1 plus L by A. Okay. Del 2 means what? This F2 by K2. Now F2 I can write this thing F1 by K1 plus L by A, F1 into L by A. Something's missing by K. K is missing. I just missed the K too. Can I? Is it right? Now if I simplify K F1 by K1 plus again F1 L square by A square into K2. Now what are the factors that we have common? F1 is the only factor that is common, isn't it? So F1 we can take it outside and we get 1 by K1 plus L by A whole square. We will take it this way by K2. Now this is what? This is our deflection. Now this deflection we are going to substitute over in this equation. We can simply substitute in this equation. Now if I want to substitute in that equation, what will I get? F of n by 1 by 2 pi. Okay. What is F? Force, that is mass into G. Can I say? F is nothing but the mass into G. So, G by mg, we can get K1, K2, K2 plus K1 L by whole square. So we will get 1 by 2 pi root over K1, K2 K1 plus K2 A by L whole square. Are you getting something like this?
Ma'am, it should be K2 plus K1 A by.
It will just, I have just taken that in a reciprocal way.
Okay, ma'am.
Just check that whether you are getting the same answer or not. This is one of the type. Now, if you have 3 members or any other 4 members, it will be changing. The deflection value will be changing accordingly. Okay. Shall I move to the next problem? Okay. This is another different kind of problem. Okay. A shaft of 50-meter diameter and 3-meter long is simply supported at the ends and carries 3 load of 1000 Newton, 1500 Newton and 750 Newton at 1 meter, 2 meter and 2.5 meter from the left support. The Young's modulus for the shaft material is 200 gigapascal. The frequency of the transverse vibration will be. So you can see the options they have given in terms of hertz. That means fix that you have to find f of n. Okay, natural frequency of this. Now this they have given in the question simply supported beam. Okay, now what will be the vibration? Now do you have any clue that how you can find out this? How you are going to find out this? They have given a shaft whose diameter has been given. Okay, the length, the total length is 3 meter. 3 different loads has been given. So I can say P1, P2, P3, right? With respective end supports. How we are going to find this this natural frequency? Now, what are the formula that you know? 1 by 2 pi k by m. Another is 1 by 2 pi g by del. That is a deflection. Now, can you
We
find
need to
out?
find
Yes, you can. You need to find out the. You need to find out what?
deflections.
Okay. Now here, how you're going to find the deflection? First, find. Here we have. Let's consider 1, 2, 3, 4, and 5 points. Okay. Now you need to find a deflection for this point when we have only 1000 Newton. You find the deflection for that. Then next you have for only 1500 Newton. Find the deflection for that. Next step, find for the 750 Newton alone. Find the deflection. Sum up all together and you will get the deflection for this overall thing. Now,
Total deflection.
yes. Now we have a simply supported beam. And here it is, let's consider the weight is not located in the mid. It is in the one of the side. Okay. So this is a load P. Let's consider here to here is A. Another end is B. Right? And total A plus B is L. Now you have to use the bending moment formulas that I have shared with you. Right? How this things, what will be the deflection for this condition? What will be the deflection? Do you remember? What will be the deflection? Can anybody say about those things? W A square B square by 3 EI into L. This is a formula. Alright. Now for the first case, when you have the load, okay, is 1000 Newton. So that was P. Okay. So on that case, what will be the A? A is 1 meter So A1 is 1 meter. B will be the other end. 3 minus 1, you will have 2 meter. L is constant, that is 3 meter. E is given, Young's modulus has been given. I you can find using the diameter. What is the I value? Pi by 64 d power 4. Right? You can find the I. So substitute all the value you will get for deflection 1. Right? Second case 2, your load is P2 is 1500 Newton. On that time, what is will be the A2? A2 will be your 2 meter and B2 will be 1 meter. L is same 3 meter. Substitute the value in the basic formula or the general formula, you will get the value of del 2. Case 3, you have P3 is 750 Newton, A3 is 2.5 meter, B3 is 0.5 meter. Substitute the value, you will get del 3. Now combine all this del 1, del 2, del 3 over here. Right? Solve and tell me the answer. Solve and tell me the answer. Solve and tell me the answer in the chat box. Okay, you can solve and tell me the answer. It should not take much time. See, one more thing here, the diameter of the shaft is given in mm. You need to convert that in terms of meter. You can write down in the chat box the answer you got. Just ensure me that you're getting these answers. For del 1, when I'm calculating, I'm getting 7.24 into 10 power minus 3 meter. Del 2, I got 1.86 into 10 power minus 3 meter. And del 3, when I substituted, I got 2.12 into 10 power minus 3 meter. Just ensure me that whether you're getting the same value or not.
Ma'am, I'm getting final one is 0.02.
Final value of f of n?
Ma'am, delta, I'm
Acha,
getting 0.02. Am
okay,
I
tell
right,
me the
ma'am?
final answer. No,
Point,
I don't have the final answer.
okay, 0.02 I'm getting.
Okay, what is the final answer you're getting after substituting?
That's a frequency. Oh, sorry.
Here they asked to find out the frequency, isn't it? So you have to sum up all those del 1 plus del 2 plus del 3 and substitute back in this equation. Okay?
Ma'am, 3.52.
Yes, 3.52. Okay? So what is the nearest answer among this thing? We have the option C. Option C, that is 3.5 hertz, right? Okay. Now, similar kind of problems that you can expect in your competitive exams. Okay, instead of simply supported beam, they can ask you cantilever beam, and from that you have to use the same concept.
Ma'am,
Okay.
could you please share the any PDF or any document where all the formulas have been written about deflection and all?
Sure, definitely. I will share that.
Ma'am,
Okay.
previously you shared a link of a video. Link of the video regarding this deflection and bending moment and shear force. So,
Yes,
ma'am,
that a special faculty will be taking class. Okay, as I've said, I think the previously, right? So
ma'am,
that's what that.
there was a formula simply supported beam with point load.
Okay,
So
that. Okay,
uh,
okay.
its deflection formula is WL cube divided by 48 EI.
No. Here that is for the mid, na. So here it is the variable. See, it is not located on the center. Here in this given problem, it is somewhere like both the side imbalanced. The load acting on the simply supported beam, one side the distance is A, another end is B.
So when it's located at center, then we use
Yes,
this formula.
yes. Okay. I
Yes,
will
ma'am.
share those formulas with you all. Okay.
Yes, ma'am. It will be really good.
Okay. Right. Now this kind of problems we'll solve. We'll before that we will move to this kind of problem. So you can expect now here they have asked only about simply supported beam. They can ask you about the cantilever. So as I've said, gate always will combine you and ask you the questions. Okay, so you need to use more than one or two concepts to solve the problem always. Now we will come to this kind of problem. Okay, now this is also another very important type of problem. Okay, now first look into this figure, right? And they have given some of the parameters, what is the angle and all those stuffs are given, what is the length and what is the mass that is acting. So whenever there is one string or whatever the members, right, and there a mass is acting, and with that mass or with the string or with any object, a spring is attached. Okay, in between the junctions if any spring is attached, so we have to follow very simple strategies. Okay, so in a string, right, if one is attached here, if any other spring is attached over here, right, so you have to follow one of the standard methods for this kind of problem. if more than 1 or 2. Okay, so I will explain you how to find out for single one, then I will move how to find out for the multiple type of springs. Now whenever, as I've said, in this kind of simple one string attached with an one mass is attached with a one string. So how to solve this kind of problem? Now first of all, remember this formula m double x, x double dot c single dot plus k x equal to 0. This was the equation of motion, isn't it? Already of any vibrating system, right? Now, whenever there will be some kind of angular kind of thing or angular motion, this will be transformed. Okay, this will be transformed in terms of theta dots. Okay, so if there was the x instead of x, it will go to theta double dot, x single dot will become theta single dot, and x will become theta. Okay, it will just transform whenever there is some kind of angle will come into the picture. It will just transform in the terms of theta, right? Clear? First point. So these are the tricks that you have to remember. Next, since there is here in this system, there is no damper, so you can simply ignore this point will not be existing. This point will not be existing, right? Now, in place of that, with this, you need to multiply, see where the mass is located. So, mass is here, right? And what is the distance from the fixed zone? The distance is L. Now, whatever the distance will be there, what you have to do is m into, if here it is given L, so write L square theta double dot. Okay, then plus, now we need to find this k value. Now k, what you have to do is to find out this k, here we have one factor k. Now k into at what distance it is located from this different or the fixed zone. What is this distance? Now here it is, the k is located at the same point where this L is located. So I can say this k is located at the point L. So k into, you have to need to make it square. Now suppose here another fixed beam is there. For an example, right? Here we have another thing, and here the distance is L by 2. For an example, here also the value is k. So what you have to do is plus k into L by 2 whole square. Okay, whatever the distance will be there, you have to just square it. Okay. Now, since it is not there, I can ignore this part, right? In this given problem, I can ignore the part. Plus, wherever there will be a mass will be attached, so what you have to do, you have to take the load of it. So load means m into g and the distance, and equate to theta equate to 0. Right? Now this can be written as theta double dot plus k L square plus m g L. Okay? This one divided by this, I'm dividing by m by L square into theta equal to 0. And this value, whatever this value, whenever I'm changing this to 1, I'm converting the coefficient value of theta double dot into 1. So whenever I'm doing that, and the remaining, the term which we'll get here is a value of our omega n. This will be the value of our omega n. Since we know this formula, that is m x double dot plus c x double dot plus k x 0. Now, if I'm dividing this entire equation with m, what will I get? X double dot plus c by m x dot plus k by m equal to 0. Sorry, this will be omega square. Okay, this will be the value of omega square. Now we know what is omega, natural frequency in terms of radian per second. Omega is root over k by m, isn't it? So omega square will become k by m. So can I say this term, right? This term will represent our natural frequency plus by m L square. Now if you want to change the root, so root, now if they ask in terms of hertz, 1 by 2 pi into omega, this value. Now you know all the values that they have given in this problem, L value, K value, M value, substitute and you will get the answer. Could you follow? Or should I repeat once again? Please let me know. This is a standard form of solving this kind of problem. This is one of the pattern. Should I repeat? Or
No, ma'am.
could you follow?
Yes, ma'am.
Okay.
Ma'am, basically we convert it when we are taking rotating
Yes.
part, then we convert m into I, matlab mass
Yes.
into moment of
Yes.
inertia.
Yes, mass into moment. The I value, it will depends that what kind of, whether it is a mass, whether it's a disk, that value will change, right? So here it is a mass. So mostly it will be there, disk won't be coming into the picture. It is a mass. So mass means I value is ml square. L square means what distance it is there, right? From that, actually, this is also one of the derivation, but this is one of the pattern. So no need to go through those all the derivations. You just need to remember this tricks here. This is one of the simple tricks. Could you follow?
Yes, ma'am. If they give disk, then what will be I? What will be the I
No,
value?
1 by 2 m L square then.
Acha, it will become half.
Yes, half. Okay.
Yes,
It will
ma'am.
become. Now similar kind of problem, if you see, now if you can solve this problem and you can substitute a value, you will get the answer here, isn't it? Now in the same kind of thing, they can ask you in this way also. They can ask you a problem like this is a fixed zone. They have one kind of rotating mass. Now from this point we have one spring, right? So another end you have another spring. Here also we have fixed, right? This is a fixed one. Now this is distance from here to here is maybe they are considering A. Now from here to here it is B. Now here to here it is L, right? Okay, this is a mass. Now in this case, what will be your equation? As I've said, m x double dot plus c x dot plus k x equal to 0. Now this is not there. Now whenever there is some kind of inclinations of angular thing, you need to convert x into theta, right? So it will be theta double dot and here it will be theta. Okay. Now whenever there is a mass, what you're going to write? Simply m into whatever the distance the mass is located, m into L square, plus what will be this factor? K factor here. Now
K1
first,
A square.
yeah, if this is K1 and this is K2, let's make it K1 and K2. So K1 into A square plus K2 into B square plus mg into L will be the theta value equal to 0. Now theta double dot plus K1 A square plus K2 B square plus mgl by ml square to theta, and this will be your value of omega n square. So omega n will be your root over k1 a square plus k2 b square plus mgl by ml square, isn't it? And if they ask in terms of hertz, just you need to put like this, right? You just need to put in this way if they're asking in terms of hertz.
Yes, ma'am.
All right. So this is one of the pattern. Now here, whatever we are studying or looking or doing this problem, it's in one dimensional form. Okay, one degree of that means one direction it is moving. Okay. Now how to find out it is a 1 degree system or 2 degree system? Do you know this thing? How to analyze whether it is a 1 degree or 2 degree? How to understand it is a 1 degree or 2 degree? The number of mass equivalent to the number of degree. Here the mass is 1, so that number of degree will be 1. If the number of masses are 2, then the degree will be 2. All right.
Ma'am,
Now,
degree represents the number of motions it is
yes,
performing, na?
degree of freedom. Degree of freedom. Yes. Okay. Now, you can get this kind of problem. Okay, let's solve this problem and tell me the answer. Here is a fixed zone. From here, one string is there and there is a mass m. Okay. Now, equally both the ends we have one spring. Okay. Both the end. This is also fixed. And the magnitude is k. Distance from here to here is a, and here to here is L. Here to here is L. Right? Now what will be the equation here? What will be the frequency? What will be the frequency? Now tell me the equation. What will be the
When
equation?
these 2K are in series, is it,
So
ma'am? Ma'am,
they
we can consider these two spring as a single spring.
they are attached over here. They are attached over here. Okay? Here, whenever you see such kind of system, that's why I'm telling you the various kind of possibilities. Okay? You should not consider in this way. Right? There's a beam which is attached over here. If there is another spring which is attached, or here if there is any spring attached, then you can consider that. Okay, there is a difference between those things, right? So previously what kind of problem you have done? There is a spring, then again there is maybe another kind of spring, there is another spring attached with one mass, right? This kind of problem is different than this one, try to understand the difference. If there is another spring attached, then the problem could have been different. Okay. So can I write ml square theta double dot plus k a square, then plus k square plus m g l theta equal to 0, then theta double dot plus k square plus 2k square into mgl by ml square theta equal to 0. Okay. So from here I can find what will be my omega n, 2k square plus mgl by ml square. Now sometimes they can give you the question in a simplified form, right? So if you want to simplify this equation, you will get something like this. So 2k square by ml square plus, here this m and ml will get cancelled, g by l. Okay. Sometimes in your options they can give you in a simplified form also. So always remember the unit is radian per second. Right? Is it okay?
Yes, ma'am.
All right. Now, let me tell you this kind of problem. Now, how will you solve this problem? This is a mass. From the mass, one spring is attached inclinedly. What will be the K value?
Ma'am, resolving the force. Resolving the force, ma'am, as in they are given.
What kind of force?
K equal to load by deflection.
K is equal to?
Load by deflection, ma'am.
Load by deflection.
Ma'am, balancing the force mg cos theta is equal to kx.
Kx. Okay.
We have mg
Mg
and cos
cos
theta also
theta equals to
kx.
kx, spring constant.
Yes,
So
ma'am.
spring.
So we can find stiffness.
Okay. So from here, what is x then?
X is given 2 millimeter.
Okay. So K means mg cos theta by x. M is your 10, right? 9.81 cos 30 by 2 into 10 power minus 3. Just check the answer. Are you getting the same answer or not?
No, ma'am. We are getting like 42.4.
See the units. Check with the units. It's cos 30 or sin 30?
Yes, ma'am. Maybe it's sine 30. I got wrong, ma'am.
Yes. It should be sin 30. Okay. Now you tell me the answer. Because we are resolving the forces, right? So when you're solving that, you're getting 24.53
Ma'am, B option.
meter. B.
Yes, ma'am.
B. Yes, it's in millimeter, right? B. Right? Okay, that's good. So this degree of freedom, equilibrium frequency, that we will take care in the next. But we will solve one more different kind of problem. Okay. Okay. Yeah, let's solve this problem. Okay, not this. This is different. Okay. This we have already done that. Okay. Okay, any question? Just a moment. Let me look into the question once. Now, in your question, they have given you the equation of motion for an 1 degree or single degree of freedom. Okay, they have given that. Means the equation of motion they have given of a single degree of freedom, and they have given the equation as 4x double dot plus 9x single dot plus 16x equal to 0. Okay. Now from here, this equation, you need to find out the what is the frequency, either in terms of hertz or in terms of radian. How will you find out that? Very simple. This is the equation, basic equation comparing m double x plus c single x single dot plus k x equal to 0, right? So x double dot plus c by m x dot plus k by m x equal to 0, and this is the value we know is our omega n square, isn't it? So if we do that same,
2 radians per second.
0.32 FN, 0.32 hertz.
so omega n will become root over 16 by 4, isn't it? So your answer becomes 2 radian
2
per second.
radians per second.
And if they ask in terms of hertz, so 1 by 2 pi into Wn becomes 2 by twice of pi, can cancel 1 by pi. So if you substitute the value of value, or they are given the options in terms of pi, accordingly you need to find out that. Okay. Now, next problem. Let's solve this problem. So they have given a cantilever beam, okay, and they have said a mass m, okay, a mass m is placed at the end of the beam, okay, cantilever end, mass m has been placed. Now from here, the length they have given as L, okay, length of the beam they have given as L. What will be the natural frequency? What will be the natural frequency? How will you find for this kind of problem? And this is one of the gate question. Any idea?
Ma'am, under root G by delta.
Very good. Yes, same concept you have to use. Is 1 by 2 pi G by delta. Now what is deflection? First you need to know the deflection. Now whose deflection will you find out here? When one end is, that means it's a cantilever beam, when the load is acting at the free end. Now what is the formula for that? You should know that formula, isn't it?
WL cube by 3 EI.
Yes, 3 EI. Right? And what is W? We can write mg L cube by 3 EI. Now just simply substitute that. Okay, simply substitute that. F of n 1 by 2 pi G by mg L cube 3 EI G, and this G will get cancelled off. So we get 3 EI by m L cube. Now sometimes they might also ask you that what will be the stiffness value for this, stiffness of the beam. If they ask what is the stiffness of the beam, they can ask lot many ways. If they ask what will be the stiffness of the beam, now you know what is that. Stiffness means they want to ask the value of K. Now this is a basic formula, f of n equals to 1 by 2 pi K by m, right? So these are the constant value. Now what is the remaining value? So can I say from here the stiffness value is 3 EI by L cube? Can I say that? Or you can directly find using this formula. This formula. What is that? Deflection equals to load by stiffness. Right? Using this formula also you can find directly. So I hope you're getting the points that they can ask you in various ways. The simple thing they can ask you in a various ways. Sometimes they can ask you what will be the natural frequency, maybe in terms of hertz, maybe in terms of radian per second, or they can ask you find out the deflection, or they can ask you to find out the what will be the stiffness value, right? Could you follow?
Yes, ma'am.
Okay, so I think it's almost time today. Next class we will proceed with the 2 degree of vibrating systems, and that is also equally important. And we will see some of the very important formula. That is how to find out the damping ratio, how to find out the this lot many factors are there to find out. Okay, damping ratios is there, then how to find out the critical damping, over damping, whether it is under damping, right? So we will see in the next class. All right, so any other question?
Ma'am, could you please share that solution?
Which solution here?
Ma'am,
Acha,
will
the